thus far we know how to prove triangles congruent using hypotenuse leg, side, 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 and side angle side. So today we get to add 2 more tools to our tool belt and use something called angle side angle and angle angle side. Okay? So on your notes sheet, if you're coloring anything in at all, it's probably going to be these words. We want if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another, then that's going to make those triangles be congruent. Remind me, what does included mean? If you include your friends, what do? You let them be apart, right? You don't keep them out a long ways away, right? You make them join up, right? So when we say included, and if you want to change that word to make something that makes sense to you, when we're saying included in geometry, we're talking about right next to, okay? Right between, infused in there, right in the middle, okay? So we can't jump. We can't hop, skip, and jump around. All 3 of them have to be snug up next to each other, all cozy and tight. Okay? So for angle, side, angle to work, we don't get to jump over a side or an angle. They have to be cozy. Okay? Like little bugs in a rug. Okay? So angle, side, angle. So let's name our triangles. How do we want to name this first triangle? BAC. I like it. Okay? It doesn't have to be alphabetical every time. So triangle BAC is going to be congruent to what? When we start with B, that means that we need to find the same angle. So E in the other triangle. And then when we said A, we need to go to D and then to F. Does everyone see why? Back when we were naming congruent polygons, we had to make sure we named the angles in the appropriate order so that they all matched up. Same thing here. And I like the fact that we started with an angle that was marked. Double, single, no mark. Double, single, no mark. Okay? These look like they're just reflections of each other, don't they? So we have to make sure we start in the right place. Questions on this one? Okay? So our next one says, hey, find this piece in your notes. Which is the included side of angle E and angle T? If I had these 2 angles marked, which side would I have to have in order to call it angle side angle? ET, which makes sense, right? These 2, angle E and angle T, have to be connected by segment ET. Does everyone see? Understand why? To use angle side angle, they have to be snug up next to each other, all close together, all touching, no gaps. And so we can use angle side angle if we have angle E, angle T, and then segment ET. Question, Dara? Or do you have a question? Okay. 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 All right. Now we want to tell the included side of angle T and angle G. So here's T and here's G. Which would be the included side of those 2 angles? GT or TG, right? This is the one that's between those. So if we want to use angle side angle, we have to have side TG. Does anybody notice a pattern here? The 2 angles are named, the segment between them is the segment that we're wanting. Okay? So you'll have questions like this. There'll be couple second questions. They won't take you very long on your assignment today. Questions about this one? All right, next, let's keep moving so you have lots of time to work. Okay, what about a non-included side? We want to know what's a non-included side of angle E and angle T. So if this is an angle and this is an angle that we're looking at, what would be a non-included side? GE or TG, okay? So there are two of them. Okay, so we don't want to use, we can't, if either one of those sides is congruent, we can't use angle, side, angle for that. Okay, because it has to be the included side for angle, side, angle. What would be a non-included side for T and G? EG and TE. T, not TG, but TE. Okay, so non-included versus included. The reason we want to know about the non-included side is because we have something called angle, angle side. Okay, this other one was called angle, side, angle because it was two angles and the included side, the one right next to it. Okay, this one is called angle, angle side because we have two angles and one of the non-included sides congruent to two angles and a non-included side. Does everyone see how that works? Angle, side, angle all snug up next to each other. No gaps, no jumps, no hops. But on angle, angle side, we're starting with an angle, we're skipping a side, we're going to another angle, and then we get the side. So only two of them are close to each other. One is separated by a side. Questions? Okay. So angle, angle side. The way I remember this one is everybody wants A's, right? In class? In your classes, everybody wants A's. So that's how I remember that one. And the other one, angle, side, angle, is NASA without the N. Okay? Make sense? Or you can find another way of remembering it. ASA, 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 and A's. Okay? So let's name these triangles. How do we want to name this first triangle? What are we going to call our first triangle? Going to go alphabetically or by angle marks? Angle marks I think makes sense. So HGI, everybody okay with that? HGI, if we started with H, we have to say what first? K, and then we went to G, so we have to go to J, so KJL. So it's not important that we go alphabetical, it's important that we make sure that we get them named properly, and if it helps you to start with angle marks, then do that. Okay? Questions on this one? Okay, so here's our last thing that we need to do. Now that we know that we have 5 tools in our tool belt, hypotenuse leg, side, 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 angle, side, angle, side, angle, and angle, angle, side, we want to be able to prove two triangles congruent. Okay, so you've got the same figure down below. Make your marks. Show that angle 4 is congruent to angle 2. So put an arc at 4 and an arc at 2. and write down your given. Angle 4 congruent to angle 2, given. Okay, what do these marks mean? RL is parallel to DC. You can make it a separate statement or keep it in the same one. It doesn't matter to me. Still given, right? So how do we show that RL is parallel to DC? What's our symbol for parallel? Yeah, the little triangle, the little half triangle, the little arrow. So this guy and this guy are parallel. Okay. So we're trying to prove RLD and CDL are congruent. These two smaller triangles are congruent. So what shall we do? I know how to prove this. I want to make sure that you know how to prove it. Thank you. I like that. Why would angle 1 be equal to angle 3? I like it. Angle 1 is congruent to angle 3 because we have two parallel lines cut by a transversal. These are on the opposite side of the transversal. They're between the two lines. So these are called alternate interior angles. And we can abbreviate that as simply alternate interior angles congruent. We write enough without having to write a novel or a book. Okay? And Nate is predicting angle, angle, side. Where's our side coming from, Nate? Okay, so angle, angle, side would mean this one or this one are congruent. Do we have any tick marks or any way to get these two congruent? Not quite. I like it. Angle, side, angle, because this middle line is congruent to itself, isn't it? Does everyone see that? DL is in both. Why can we say that? Reflexive. And now the triangles are congruent. Because we have an angle, a side, and an angle congruent to an angle, a side, and an angle. They're all snug up next to each other, no hops, skips, or jumps, right? The included side, so we want to put that included side in the middle. Make sense? Questions on this one? Okay, assignment. Tomorrow we have a worksheet.